stuff on this. First thing, on your option 10. First thing I want to do, because I was looking at the test, I showed Brandon the test the other day. Oh, I don't know about that. All right, first thing, because I know there's a problem like this on the test. This is just a problem I'm making up here. A triangle has, fellas, up here, two sides of length, I don't know, make that two numbers for me.
2 and 4.
Say it again.
2 and 4.
2 and 4. 2 and 4 inches. All right. What can you say about the third side? I know there's problems like this on there, so that's why I'm just writing this one up here, because I don't think there's any on the worksheet that are this way. We had a theorem that said what about any two sides of a triangle?
Third side always has to be.
All right, so you add any two sides, and that sum's got to be more than the third side. So if you add two sides, the sum's got to be more than the third side. So what can I say about this third side?
It has to be 1.
How do I find, if I'm going to write it this way with the alligator mouse, that's probably the shortest way to write it. How do I find this low end down here? Subtract. So down here you subtract the two sides. That's going to give you the low amount that third side could go down to. How do you find the high end? Add the two sides. Make sure you know this. I'm doing this for a reason. So what I get down here? 4 minus 2, which is, how about over here?
5.
2 plus 4, which is, give me an example of what that third side could be. Could be 5, 3. Give me a number that would not work for the third side. 7, 1, 237. How about 6? Would 6 work? Why would 6 not work?
It's not less than.
Okay, it's not less than 6. Give me the highest possible number that would work for the third side. 5.9999, so on, so on, so on. Give me the lowest possible number that would work. 2.00001. There's got to be a 1 there somewhere, right? So it's got to be between those two. So if I gave you a triangle and I told you to, is it possible to have a triangle that's got sides 2, 4, and 6? What are you going to tell me? It's not possible. It's not possible. Give me a reason. Why is that not possible? What's the easiest way to explain to me? Because I know there's a bunch of problems on the test that say explain why or why not. So you say 2 plus 4 should be greater than 6, is it? That's not true. So it can't be a triangle. It's not true, so it can't be a triangle. Because 2 plus 4 actually equals 6. All right, number 1 on this paper. Again, we're going to go through a bunch of these. We're going to move extremely quickly. I would write down stuff. That's up to you. This goes in your notes. Never know when we take this test what might happen on the test. says list the angles in order from smallest to largest. List the angles in order from smallest to largest. All we're going to do is go smallest angle, then next angle, then next angle. How do we know which angle in this picture is the smallest since they didn't give us any numbers for the angles? It's across from the what? Across from the smallest side. Which side's the smallest? Draw in your arrows there if it helps you. Which angle's got to be the smallest then? Angle N. So angle N's the smallest. How do we know which angle's the next smallest? Which one's the next smallest side? So what's the next smallest angle? Angle L. Make sure I can tell your angle symbols and stuff. And then what's that tell us about angle M? It's the longest, it's the biggest. So that would be our answer on that one. If you wanted to use the alligator mouse, you could. It would look something like this. Angle N. Remember, make your alligator mouse bigger than the angle symbol so that I can tell the difference. Angle L. Oops, didn't make that one very big. And angle M. Either way. Either one of those answers work all right. Number 2. Could we find x this time? 5x plus 5x plus 8x equal 180? Why not?
That's just the angle.
That's the angles, not the sides, so don't do that. Don't say 5x plus 5x plus 8x equals 180. We're not dealing with angles there, we're dealing with sides. Do we know what 3 sides of a triangle always got to add up to equal? There is no special number, right? So that doesn't help us. So how are we going to figure out which angles are the biggest and which one's the smallest? What's something you could tell me about x?
That's probably the biggest one. When you're writing out the alligator mouse, could you spell like the equal to sign?
Maybe. That's part of it. So you guys are, forget that these two are the same, Joe. Just how could we figure out which one's the biggest angle, which one's the smallest angle?
Because angle E looks like it's obtuse.
Be careful of that because what do we know about my drawings? Not very
That's
good
a drawing.
usually.
That's pretty good.
X is still have to be a number, right? So could you come up with a number that we could stick in there for x?
Yeah.
1, 7. What kind of number can't x be this time? Can't be a negative. Because if I stuck in a -2 right here, what's 5 times -2? How many sides have I asked you to draw this year? Or how many segments have I asked you to draw where the length was -10? None. You can't do it. So can we tell that x has to be a positive here? And using your brain, using your common sense, if x has to be a positive, which of these 3 sides has to be the biggest?
The 8x.
The one with the 8x. This has to be the biggest side. Because 8 times something's always going to be bigger than 5 times something. So what do we know about angle E right there? It's the largest. Angle E has to be the largest. Well, now Joe started to tell us about these two because he noticed something about them. What's true about those two? They're equal. They're actually congruent to each other. So is one bigger than the other? So what do we know about angle D and angle F? They're congruent. They're the same. So does it really matter which order we put those two in?
No.
So tell me how I'm going to list these angles. What's the smallest?
Angle D.
Angle D.
Is congruent to angle E. Oh wait, just kidding. Angle D, angle E,
What goes next?
and then angle F. No, I'm actually joking.
If we're just listing them in, we're just listing them in order. Angle D,
Oh, F.
angle F, because those two are the same, right? And if it helps you, Shelby's having trouble back there because she's thinking those two are the same.
It's less than.
If it helps you, write same above them or something like that to tell me. And then
It's less than.
we know that which is the biggest? Angle E. Now again, I didn't use the alligator mouse this time. I just used commas and put them from smallest to largest. Could I have used the alligator mouse if I wanted? Jeremiah enjoys drawing the alligator mouse. Takes him back to his 3rd and 4th grade days when he enjoyed school and was all happy and everything was fun and playful. Right, Jeremiah? So if he wants to draw them, draw them. Number 3. What's the first thing you do? You see this picture. What's the first thing you do? For the rest of the year, if you see a picture of a triangle and it's got 2 angles in it, I don't care what they're asking you to find, your mind should jump right to doing what?
Finding the last angle.
Finding the 3rd angle. Go ahead and find the 3rd angle. You should have your calculators out anyway, right? 21 plus 87. Subtract that from 180.
Wow, man, all
Anybody know what it is? 72. Once we have that, now we're going to list the sides in order from smallest to largest, or longest or shortest to longest this time. The sides, I think that's what number 3 says, right?
Yeah.
Shortest to longest. Which side is the shortest? How can I tell which side is the shortest?
Across from the smallest angle.
Across from the smallest angle. Well, 21 is the smallest angle, so which side has to be the shortest? Segment AB. Make sure on the test, you AB with the symbol above it. Which angle is the next smallest angle? At which angle? 72, right? So which side's across from it? AC. Make sure you use your symbol. Then what's that tell us about this side across from the 87-degree angle? It's got to be the largest, the longest. So segment BC. That's in order from small or shortest to longest. What if I wanted to list it from longest to shortest?
And go backwards.
Just turn it around the other way, right? Make sure you read problems carefully on the test, because Joe, we know that I'm sort of a jerk about stuff like that, right? And I'll be telling you shortest to longest. We might do 10 problems on test. Shortest, longest, shortest, longest, shortest, longest, shortest, longest, shortest, longest. Then all of a sudden I'll get to that 11th problem. I'll say longest, shortest, just to mess you up. Number 4.
Oh,
Now this time, could we set up an equation
yes.
and find x?
Yes.
Because what do we know about 3 angles of a triangle?
Absolutely.
They add up to 180. So we could set up equation, but I'm going to tell Aiden, you don't really need to. If this angle is x, again, what do we know about x? It has to be what kind of number?
Positive.
It has to be a positive, can't be a negative. So we know x is a positive. Well, if x is a positive, which of these has to be the biggest angle? The 2x has to be the biggest. That has to be the biggest. 2 times some number, some positive number is always going to be bigger than just that number, and it's always going to be bigger than just that number minus 4. Which one of these two is going to be the next biggest? X minus 4 or x? X. So that's the middle one. And then what's that make this one? The smallest. Now, if you wanted to set up the equation, because you don't believe me, you wanted to set up the equation, actually figure out what x is and plug them in there, go right ahead. We want to go shortest to longest again on our segments. Which segment, which angle is the smallest angle? That one. So which segment's got to be the shortest? PQ. So PQ, segment PQ. Which one's the middle segment?
Segment PR.
Segment PR. Peyton's going to look right here and make sure, because does it look like PQ is shorter than PR? No, not really. And that goes back to, we don't go by what Mr. Eversole draws, right? And then which one has to be the longest segment? QR, the one across from the 2x. So that should be our answer on that one. Number 5. 15, 37, 53. Are these possible to make a triangle? It's a yes or no question, but again on the test. On here it's a yes or no question. Well, no, it does say explain, doesn't it? On the test you'll have to explain to me. Is it possible to make a triangle that's got a side 15 units long, 37 units long, and 53 units long? If you're saying yes, then we need to show it. How can we show that yes, that's possible? 15 plus 37 should be what? Greater than 53, is it?
No, it's less than.
It's not? So can we say yes?
No.
So what's our answer?
No.
No. 15 plus 37 is what? 52. So what's that tell us? Can't be a what? Can't be a triangle. There's no triangle in our world that has sides those 3 lengths. Number 6. Yes or no?
Yes.
Write down yes again, Joe. I'm hoping you're right this time so I don't have to mark out, make my paper look all sloppy. 9 plus 16 should be greater than 8. This is how you would show me if I ask you to explain it. 9 plus 16, is that greater than 8? That's true. Is that enough to say, yeah, it's a triangle? No, we got to do all of them, right? What's the other?
16 plus 8.
I heard 9 first, I started writing. 9 plus 8 is greater than what? 16. Is that true? Yeah. And then what's the last one?
9 plus 8. Oh my gosh.
16 plus 8 should be greater than what? 9. Is that true?
Yes.
So can it be a triangle? Yeah. Which one's it easier to prove? That it is a triangle or that it's not a triangle? It's not. If it's not a triangle, all you got to do is find that one where it doesn't work. Put that in there. If it is a triangle, you got to show all 3 parts. Number 7. Describe the possible values of x in the figure. Oh, I'm sorry. Mark out number 7. I don't like it. You want me to actually do it?
No. It's on the test.
It looks easy.
It's not hard, but I didn't put anything. Number 8. I'm not going to do number 8 either, but we are going to set up an equation for it. They tell us this angle is 3x plus 16. Somebody help me out. Is that a 6x plus 4? Is that right?
I have trouble with.
The one angle outside of the
Oh, that's a 9x. Is it 9x plus 16?
Yeah.
What's the other one so I don't even read it wrong?
4x minus
4x minus 2. We had a theorem last chapter or 2 chapters ago, I can't remember. What kind of angle is that angle? It's called a what kind of angle? Exterior angle. We know that that exterior angle, and how does it relate to these 2 interior angles? Those 2 add up to equal that. So tell me the equation we could set up. 9x plus 16, is that right?
Yes.
So that's the equation. This angle plus that angle should equal that. We solve that, we find x. Once we find x, could we find out what the measures of the 3 angles are? And once we find out the measure of the 3 angles, could we figure out stuff about how long each side is? Yeah, biggest angle across from the biggest side, smallest angle across from the shortest side. Number 9, look at number 9. L there, N, M, please be paying attention. If I write something wrong, please tell me. Is that right?
There's an X.
Oh, there's an X. List the angles of the given triangle from smallest to largest. So same thing we were doing. What do we know about X again? We've said it like 3 times already.
It's positive.
It's got to be a positive number. Got to be a positive. Which of these sides has to be the shortest side then? That's got to be the shortest. All right? That's got to be the shortest. Which one has to be the longest?
X plus 10.
X plus 10 is always going to be bigger than X plus 8, right? As long as X is a positive. So that's got to be the longest side. Then that makes this the middle side. We want to list the angles from smallest to largest. Which angle is going to be smallest, and how do you know it? Angle L, because it's across from the smallest side or the shortest side. So angle L. Which one's going to be the next smallest? Everybody see that? It's across from the middle one, so angle M is going to be the next smallest angle, and which one's the largest angle then? Angle N, because it's across from the longest side. So be able to list those. Again, if you wanted to list them using the alligator mouse, angle L is less than angle M, which is less than angle N. Make sure I can tell the difference between your inequalities and your angle symbols. Number 10. Problems like number 10. I love putting problems like this on the test. Poor Abigail back here, as soon as she sees that fraction in this problem, what happens to the problem? It gets skipped. Oh, it gets skipped because it's got a fraction in it. Doesn't affect anything in this problem other than you got to know that 3/2 is bigger or smaller than certain things. All right? So if I'm looking at this one, this is U, this is V, that's W. We want to list the angles, smallest to largest again. Which angle is going to be the smallest? Which side's the smallest? X. So what's that tell us about that angle right there? It's got to be the smallest. So angle B's got to be the smallest. Now of these two, which one's smaller? 3/2 X or 2X plus 1? What is 3/2? 1.5. If I take 1.5 times something or 2 times something, which one's going to give me the bigger number? The 2 times it, right? So what's that tell me about this one? That's the middle one. That's going to be smaller than the other. So what's that tell me about angle U? That's the middle angle. And then what's got to be the largest angle? Angle W. Did that 3/2 affect this? If it was confusing you there, then make it 1.5x so you can see it. So angle U is the smallest, or I'm sorry, angle V is the smallest, angle U is the middle angle, angle W has to be the largest. Do we know the measure of angle W? Do we know it's more than 80? Do we know it's more than 50? Not really. There's nothing we really know about it. We just know it's the biggest in that triangle. Actually, we could figure out that it's more than 50. How come it can't be 50 degrees if it's the biggest? What would that make these other 2 angles? That makes something, one of them has to be more than 50, right? Yeah, that's the number. That's the problem number. So 50 wouldn't work there. We could come up and say, well, angle W has to be at least this much, but number 11. RQS. Got 19 degrees here. Is that a 48 degree? What's the first thing you're gonna do on this one?
Find the missing angle.
Find the missing angle. Somebody do that for me real quick. Find that angle Q right there. I'm not even gonna listen to what Sam said because he knew it was wrong.
113. He said 67.
Yeah.
What'd Sam do?
48 plus different.
He added them together, but they forgot to do what? Subtract it.
He said what?
What's the shortest side in this triangle?
QS.
Because it's across from the smallest angle. So QS, shortest. What's the next shortest? Across from the 48-degree angle. QR, RQ. And then that's an obtuse angle, so it's always got to be across from the longest side. What's it? Segment RS. Make sure you're using your symbols, 2 letters to name those. Number 12, we're skipping number 12. Number 13. I like these problems. On problem 13, first thing I'm going to do, how many triangles are in this picture? 2. And what you should do, maybe off to the side somewhere, you got to separate those triangles. You can't look at them together. That's B, that's D. Again, if I write something wrong, somebody please tell me. That's 75 degrees. That's 70 degrees. Angle there. Let's just deal with that triangle at first. What's the first thing we're going to do there? Find the other angle. Somebody do that real quick.
35 degrees.
35 degrees. Everybody agree with that? Tell me which side's the longest side in that triangle. AD. So I'm going to write long. Which one's the next longest? The middle one. AB. So I'm going to put middle there. And which one's the shortest? BD. I'm going to put short there. That's all I know right now. I don't know anything else. I'm going to come over here and draw the other triangle off. Looks something like that. This is B, D, what's that, C? It's 40 degrees, 80 degrees. What's the third angle in that one? 60. Everybody agree with that? Aiden's going to watch closely on this one. These are the kind of problems I like, Aiden, because it makes you actually think things through. It's like a mind or like a teaser problem or something. Which side's the longest side in this triangle? BD. So that's the longest because it's across from the 80-degree angle. Which one's the middle one? BC, that's the middle. And then which one's the shortest side? Now we want to list from shortest, let me read before I say that. Shortest to longest, all the segments in here. How many different segments are in this original picture?
6.
In the original one, there's 4.
5. There's 5, right? So we should have 1, 2, 3, 4. When we're done, we're going shortest to longest. We should have 5 segments listed out in order. Now the bad thing with this, how can I compare this triangle and the lengths of its sides to a different triangle? We don't have a theorem for that. But what we do have is if we look at this, can we figure out in this whole picture which side has to be the longest and which side has to be the shortest in the whole picture? Look at what we have here. What do we know about this segment? It's the same as itself, right? In this triangle, it's the shortest length. In this triangle, it's the what? Longest. Well, if it's the shortest in this one, it's the longest in that one, what's that tell us about all the sides in this triangle? They're all less than these over here. So which side out of all these has to be the very smallest? The shortest one out of that triangle over there, right? Now, if that confuses you, then maybe try something like this. try something like this. Let's stick a number in here. Let's make up a number for this side right here.
110.
110. Had to make it something hard, didn't we? If it's 110 over here, what is it over here? 110. Give me a number for this side over here. It's got to be less than that, right? So 70. How about this one?
35.
30. Give me something that actually works, because 35 won't work. 40 won't work either. 30. 30 won't work either. Too small. How come none of those sides will work? What's 20 plus 70?
90.
Is that bigger than 110?
No.
Then we have a theorem that said any two sides got to add up to be more than the third side? 50. All right. So that's possible. This is 110. Tell me how long this side could be.
112.
112. How about this side?
133.
133. Does everybody agree with those? Now, if we plug in those numbers, and as long as it fits long, middle, short, like we have listed there, should we be able to put them in order from smallest to largest? What's the very shortest one? 50. So segment DC, that's going to go right here. What's the next shortest out of all of them in the picture? Segment BC, that's going to go next. Then what's the next shortest? BD. Are we going to list BD twice? No, that'd be sort of stupid, wouldn't it?
AB.
Same thing. What's the next one? AB. Segment AB, good. And what's the longest out of all these pictures, or all these segments? AD. So sometimes you can use the triangles when they match up like that to show what you have. All right, flip over to the back side of the paper. What's on the back side, isn't it? Yeah, that's a good one. Now, we did have a theorem where you can actually deal with two separate triangles. The hinge theorems. I can't remember who I used in here. Maverick, did I use you? Who was it that I used that day? Sam?
It was Sam.
Sam used
Because
it?
he couldn't hold it up.
He gets out of bed.
So if we have this angle, what happens to this third side of the triangle is that hinge gets wider.
It's longer.
It gets longer, right? So if we start off, these two sides are the same in this triangle. You look at that third side, it's sort of short over there. Then I come over here and I have a new triangle, and the two sides are the same, but now I have a bigger angle here. What happened to that third side? Got bigger, all right? So if I'm looking at this, and it asks us segment AC compared to segment DF. Should have probably put the circle in there so you guys could remember back to your 3rd and 4th grade years, because every time you see that circle, you know to put what in it? The greater than or less than symbols, right? So AC and DF. AC is right here, DF is right here. Well, DF's across from a 110 degree angle, AC is across from a 115 degree angle. So what's that tell us about segment AC?
It's longer.
It's got to be bigger, got to be longer. Which symbol goes in here then? Greater than? Everybody agree with that? So write that in that little blank there. We're going to do this one, then we're done. I'm tired of doing these. 6, 6.
That's pretty much what the whole page is.
Yeah, I know, they're all the same kind of setup, aren't they? That's congruent to that. Did I get everything? I'm not going to draw the angles here. We'll just put the little blank with the circle. We're going to put one of the symbols in there. What do we know about these? We got two triangles here. What do we know about segment HI and segment IJ? They're congruent because they're both 6. What do you know about these two sides? They're congruent. What can you tell me about this triangle and this triangle? They're congruent. Give me a reason. 3 letters. That's what we'd use to get to it. What 3 letters? Remember, to prove a triangle congruent, what are some of the letters? What 3 letters?
Well,
What 3 letters to prove the triangles are congruent? How about this? Hope you guys don't forget all this stuff. Not gonna do well in the final exam. So we know those 2 triangles are congruent. Well, if those 2 triangles are congruent, what can you tell me about those 2 angles right there? They're congruent. So which one's bigger, this one or that one? Neither one. So what are we gonna put in there? Equal. All right, these are your notes for today. Go ahead and start copying those down. If you want to skip space in between them, that's up to you. I'll probably just go on to a different slide and do like 1, 2, 3 and list everything. You'll have to read off to me what number 1 said, what number 2 said, so on, so on, so on. We're gonna write stuff. It's not. That's up to you how you do it. Notice on this, it says theorems and formulas first of all. What formulas are we going to use? Distance formula and midpoint formula. Make sure you know those. Guarantee there's a couple problems on there where you have to use them. So you might want to jot them down again. The theorems, every single one of these, and some of them more than one, had a theorem that went along with them. We're going to talk about those theorems. For perpendicular bisectors, you might want to write perpendicular bisectors of a segment. And for these down here, these are the ones with triangles. Ricky's going to make sure during the test, Ricky, if I catch him turning his head to the right over there and looking at my triangles on the thing, I'm going to give him a 0, right? Probably not. All right, so if Kelsey's sitting right there,
See how straight that line is?
Hey, that's a good one.
Yeah, it was.
First of all, all lines are what? Straight. So don't say how straight that line is. Say how straight Eversole got lucky and drew that certain thing that he drew.
Perfect. That looks like you like.
Wow.
Right there.
So everybody got that? Because I'm going to switch slides.
No, he doesn't.
Yes? Yep. Number one, what number one say? This is what you might want to write down there underneath somewhere, or wherever you want to put it. What number one say? Perpendicular bisector of a segment, right? We had a theorem that talked about the perpendicular bisector of the segment. And that theorem said any point on perpendicular bisector is, does anybody remember it? If there's a point on the perpendicular bisector of a segment, what do you know about it? Let me draw it, and I bet it refreshes your memory. If I got this segment right here, segment AB, and I draw in a perpendicular bisector. First of all, what's a perpendicular bisector do to that segment? Splits into two congruent segments and forms what? Right angles.
Oh, is it a transverse?
Sort of, but that's not what we're looking for here. What do we know if I pick some point that falls right there on that perpendicular bisector? We'll call it point Q. It's equidistant from A and B. So any point on the perpendicular bisector is the same distance from the two endpoints of the segment. So if I have Michael come up here and put a point up here, and Michael picks this point right here, what do we know about Michael's point right there? It's the same distance from A as it is from B. Then I have Tristan come up and he puts a point right here. What do we know about it? Same distance from A as it is from B. So that's for perpendicular bisector. Number two, angle bisector. First of all, what's an angle bisector do? Bisects an angle. What's that mean? Splits an angle into two congruent angles. So that's an angle bisector there. If I could draw a little better. See, I used up all my talent on that one a few minutes ago, didn't I? Perfect. Perfect line. So we have this. We know that those two are congruent. We had a theorem. The angle bisector theorem said any point that falls on the angle bisector. So if I pick that point right there, that's point E. What do we know about that point E? Equidistance from the two sides of the angle. It's the same distance from both those sides. Remember, distance has to be given with those right angle symbols. It's got to be perpendicular. You can't have from E to this isn't going to be like that. That can't be a distance. It's got to come together and be perpendicular, form a right angle. So angle bisector. Any point on angle bisector is equidistance from sides of the angle. Any point on the angle bisector is equidistant from the sides of the angle. Shocking. Feel if I breathe. Have a gift, you think I'd really shock you. everybody have that much? Number 3. What number 3 say? Help me out. Theorems. That's all it said was theorems. We just covered those 2 theorems. What number 4 say? All special segments and lines related to triangles. All of them over there on the sideboard. Let's do this for number 4. Switch slides on me, didn't it? Let's do this. Let's say I tell you something's a median. Tell me something you're going to think of as soon as you hear the word median.
Centroid.
Centroid. Don't say middle. I don't like the word middle. Midpoint. Thank you. And if you hear midpoint, you think of congruent what? Congruent segments. Now, the centroid actually had a theorem. Does anybody remember what that centroid theorem said? Probably spelled it wrong. Nobody remembers the centroid theorem? If I told you this was a centroid. If I told you that's a centroid, mine's drawn horribly this time. What do you know about that segment, the distance from the vertex to the centroid, and how it relates to that segment, the distance from the centroid? Right. Now you got to be careful because everybody's getting, I had you write it down 2 different ways, and everybody's getting those 2 confused. If we're looking at the whole segment, we know that this part is 2/3 and this part is what? 1/3. But if I just told you this segment right here, if I told you it was 10, how long's this one? 5. This one is double what that one is. There's 2 different ways to think about that theorem. All right? So if I told you the whole thing, that median right there, and that's the centroid, if I told you that whole thing was 33 inches, how long would this part be? 22. How long would this part down here be? 11. Notice this one's double what that one is. All right? So don't get the 2 different ways that we talked about confused. Altitude. That's the next one over there, next triangle over there on the side. As soon as you hear the word altitude, what should you think of? Orthocenter. Orthocenter. That's the point of concurrency of all 3 altitudes, right? What else? Height, maybe. I'm not going to write height, but give me measures, angles. As soon as we hear altitude, what should you think? You have what kind of angles? Right angles. Well, that worries me. If you hear altitude, you got to think, hey, I have a right angle somewhere. Wherever that altitude touches that side of the triangle, it's got to form a right angle. And as soon as you know right angles, you should think of what measure? 90 degrees. Got to make sure you know that. Guarantee there's a problem on the test, and it'll have a triangle like this, and it'll tell you that segment AB is an altitude. And they'll tell you that this angle right here is 2x plus 10. Well, what equation can you set up?
2x plus 10 is 90.
2x plus 10 equals 90. Because if this is an altitude, that's got to be a right angle. So 2x plus 10 has to equal 90. You got to be able to set up that equation, then solve it, and go from there. So altitude, as soon as you hear that, right angles, median, midpoints, congruent segments. We know that these segments are congruent. We also know that theorem about the centroid. Was there a theorem about the altitudes? No. Next one, perpendicular bisector of a triangle. Perpendicular bisector of a triangle. As soon as you hear perpendicular bisectors of a triangle, what should you think of? Look over there. Right angles, I heard that. That'll work. It's part of it. Circumcenter. What else? What's bisector tell us? Bisects the side, right? So congruent what? Congruent segments. Anything else? We had the circumcenter theorem. Circumcenter theorem. The circumcenter theorem said, if I drew a triangle, and I tell you that this is the circumcenter, and my pen's way off. I tell you that that's the circumcenter. Does anybody remember what that theorem said? You guys tried to use it earlier. Nobody remembers. Equidistance from where? The corners. All right. So the circumcenter theorem says that that circumcenter right there, the point of concurrency of all the perpendicular bisectors, wherever that point is. Remember, I had one of them down here on the wall. I erased it because I think it was Brandon saying that it distracted me. So I erased my point down there, but that's the circumcenter. What do I know about the distance it is from this corner, distance it is from that corner, and the distance it is from that corner? They all got to be the same. So circumcenter theorem says circumcenter is same distance or equidistance, if you wanted to write that out, the same distance from all three corners. Circumcenter is the same distance from all three corners in a triangle. So we've had medians, altitudes, perpendicular bisectors. What was the fourth thing that we had for triangles? Angle bisectors. As soon as you hear angle bisector, what should you think of? Congruent angles. Because if you're bisecting an angle, right? What's the other one? I thought I heard another one. In-center. That's the point of concurrency. That's the point where they all come together. Sorry, my writing's not doing very good now. So congruent angles, in-center. Anything else? That's probably about it, right? So if I draw another triangle, and I tell you that that right there is the in-center. Devin, you understand that I'm just sort of putting points at random in here, right? But if I tell you that's the in-center, we had a theorem. What did the in-center theorem say? In-center is what? Equidistance or same distance from what? Is it all the corners again? It's the sides, isn't it? This one goes to the angles, the circumcenter goes to the angles, this one goes to the sides. So it's equidistance from all three sides or each side of the triangle. Now remember, when I go to the side, can I run this like right there? Is that where I want to go to that side for the distance?
No, you're going straight.
It's got to be perpendicular, right? So that distance, wow, mine's way off, isn't it? So Devin understands that's probably not the in-center of this triangle, right? Because if it was, those three lengths right there should be the same. All three of those got to be the same length. So if I have a question, let's see. I'm making up a game. I've been trying to build this game at my house for a while now. I don't like cornhole, but I like this other game. I don't want that. I don't know why I just drew that. Need a triangle. Oh, that was sort of stupid. I'm making up this game, and I'm going to try to make millions of dollars off of it so that I can retire from teaching. And I have this, and I want to put a hole in the middle of that triangle. But I want that hole to be where it's the same distance from the three sides. Where am I going to drill that hole at? At the end center. Right? At the exact end center point. Don't say, so I don't know whether Brandon was correct there or if he was just saying in the center of the triangle. Means the same thing, right? So if I want it to be the same distance from here as it is from there, as it is from there, I'm going to find the end center of the triangle and drill the hole right there. Right? What if I want the hole to be the same distance from the three corners of the triangle? Then what would I find here? Which one is it? The circumcenter. The circumcenter, because the circumcenter is the same distance from all three corners. So make sure you know those two things. What would the next one say? Mid-segment. Is that number 6? Mid-segment. Oh, that's 5. Mid-segment of a triangle. What is a mid-segment, first of all? What do I got to find on this triangle if I wanted to draw a mid-segment?
The middle of each segment.
Middle of each segment, midpoint of each segment. So I'm going to find maybe that right there is pretty close to the midpoint. That right there is pretty close to the midpoint. What's that segment right there called? That's the mid-segment right there. We had a theorem about the mid-segment. First of all, you know that the mid-segment and this third side of the triangle are what to each other? They're parallel to each other. So they're parallel. That's one of the things. And what do we know about the length of the mid-segment and how it relates to that third side? It's half of it. So if I told you this mid-segment was 12, how long would this third side be? 24. Does everybody agree with that? All right, so this is half of that. Come on, pen. If I told you A, E, and C are all midpoints, pick me a segment in this picture.
AC.
AC. So I have segment AC. That's the one that Joe picked. Tell me 2 other segments in this picture that are congruent to Joe's AC. Segment AC. FE, good. And ED. If these are mid segments, then that and those 2 are congruent. How about segment AE? Give me 2 segments that it's congruent to.
Segment BC and segment CD.
Segment BC, segment CD. So if I told you AE was 10, what do you know about segment BC? 10. How about segment CD? How about segment BD? 20. So on, so on, so on. Be able to find all that stuff, whatever I give you. Do not get mid-segment confused with what? Midpoint. What else? Medians. A lot of you on the quiz that we took got medians and mid-segments confused. Make sure you don't get those 2 confused. A mid-segment goes from one midpoint to another midpoint. What's a median do? Goes from a midpoint to a corner, all right, or a vertice, a vertex. Make sure you don't get those 2 confused. Know what you're dealing with. What'd the next one say? Theorems. Is that what it said next?
Inequalities of the triangle.
Oh, the inequalities. Number 6. The inequalities. We just got done covering this, right? So, a couple of things on the inequalities. Let's do one of the theorems. Any 2 sides must what? Must add up to, not at least, more than what? The third side. Any 2 sides must add up to more than the third side. Then I'm going to sort of summarize on the whole bunch of other theorems that we had that went along with this. Biggest angle is what? across from largest side, or across from longest side. Smallest angle is across from what? Smallest side. I'm not going to write all those out. You can write them all out if you want. Biggest across from biggest, smallest across from smallest. Whether it's in one triangle, two triangles, whatever. Tell me what that third side could be real quick.
16.
Could be 16, 14. Give me a way that we could not just sit here and guess.
5 plus 10.
5 plus 10, that's 15, right? And then how could we get the other end?
15 has to be greater than the other side.
How could we get the other end?
Subtract.
Subtract 10 minus 5, what's that give us?
5.
Now tell me what we can say about this third side. That has to be between what two numbers?
5 and 15.
5 and 15. The third side of that triangle has to be between 5 and 15. Could it be 5?
No.
No. It could be 5.001, right? Give me a number that would work there.
14.999.
14.997, I heard, so on, so on, so on. I moved them earlier today. You didn't get one stacked up. I'm gonna have fire tomorrow. You're fired.
Hey, don't care.
He'll care. I'll take some other class then. On this, usually on the review packet, I tell you to do a certain number of problems. This time, I want you to do them all. Oh, shucks. A lot of them are multiple choice.
Exactly.
Do them all.
Exactly what I
Test on Thursday. Test on Thursday. Study. If you're not sure, come in during intervention. We'll go over some stuff. Peyton was talking about keeping his grade where it's at right now. He might want to make sure he studies for this test.